Okay, this is another application question on hypothesis testing. And you can read it. The label on a pack of dates, fruit reads 500 grams. So they're saying that the weight is 500 grams on that pack. And then they tell you that weights of all such packs are normally distributed. This is good to know. For a sample of 9 such packs, so let me write here that the sample n equal 9, we got the sample mean, or the average weight, is 503.8 grams, and the sample standard deviation is 9.1 grams. And then they tell you at a 10% level of significance is alpha, 10% is 0.1, test the hypothesis, and then they give you the null and alternative hypotheses. So now, if you remember from the previous part, I told you that the first thing that you do is decide on the type of test that you have. Because in the alternative hypothesis you have strictly bigger, this means that it's a right-tailed test. So this is right-tailed test immediately. And the level of significance is 0.1. But there is one thing here that you should notice. You notice that what you were given was not sigma but S, the sample standard deviation. And because S is given, and it's a normal distribution, so if S is given, this means, this means that sigma is unknown. We don't know it. And we know that also this is a normal distribution. If you read from the beginning, I even put a red line under it. So we have a normal distribution and sigma is unknown. So you go here. So sigma is unknown, and I have a normal distribution. So this means that we are going to use the t test in this case. So we need to compute the critical value for the t-test. And also remember the degrees of freedom here that you need to compute. It's just the sample size minus 1. So I'm going to go back and say that because n is 9, my degrees of freedom in this case will be 9 minus 1, which is 8. So a lot of numbers to keep track of. Okay, so now we know it's a right-tailed test. So let me just summarize. So first thing is that we know that it's right-tailed plus alpha equals 0, 1. The plus is not a real plus. It means that this is we know also. And also, maybe better I just say and instead of this. So we have this, and we know that the degrees of freedom is 8. And we know that we need to do the t distribution test to find the critical value, the t critical value in this case. So remember these numbers now. The alpha 0.1 and degrees of freedom 8, and it's a right-tailed test. Right-tailed means it's a one-tailed test. So you'll go to the t-table, you find that it's a one-tailed test, degrees of freedom 8, and level of significance 0.1 or 10%. So now the number that we will get, if we look here, it's there. So you can say here, therefore, my critical value is 1.397. Because it's a right-tailed test, you take it as a plus. You don't put a negative. You would have put a negative if it was a left-tailed test. If you look at part 3 of these videos on hypothesis testing. So now we know the critical value. So let me put it here. So this t critical value, let me put CV instead. The critical value that we found was 1.397. Okay, very good to know. This is the point here, of course. And remember that the critical value divides the distribution, the normal distribution, into 2 parts. One is the rejection region. For a right-tailed test, this would be the rejection region, and this is the non-rejection region. So what we have to do now is compute the test statistic, which is from this formula. Remember this t. Now we need to compute the t and compare it to the critical value that we have. So let me go and compute the t. Remember the formula, x bar minus mu over s divided by radical n. So our second thing to do is the test. Oh, okay, one thing we have to say here is that we found that the critical value that we just found is 1.397. So keep this in mind. And remember also it's a right-tailed test. It's important. And the next step is to compute the test statistic. The test statistic in this case is t equal, remember the formula, it's x bar minus mu over s, because s is given, not sigma, over radical n. And in this case, x bar, look up, it's here. So it's 503.8 minus mu. Mu, you get it if you look at the previous part when we solved another question. It's the number that you have here or there. You know, any of these two, they are the same number. So minus 500, that's the mu for us, divided by s, which is 9.1, over radical n. N is 9. Notice here you use n, not degrees of freedom. Degrees of freedom just to find the critical value. And so if you compute this on your calculator, you would get 1.25275. But for t values, if you go to the table just to know to how many digits do I do, you see that all of them are to 3 digits after the decimal. So this is why I will do just 3 digits here. So this would be 1.25 and then 7 after the 2, so it becomes 3. 1.253. So last thing that we have to do is to either reject or not reject the null hypothesis. So I'll leave this in a box, and we will figure it out by going here. And remember the test statistic, we need to find where it is in the graph. Statistic is the one we just found is t equals, let me look it up again, it's here, 1.253. So it's 1.253. Now you ask yourself, is this number bigger than the critical value or smaller? Notice that the critical value is 1.397. So 1.253 is somewhere here. It will be here. So where does it lie? In the non-rejection region. Okay? This is for a right-tailed test. Again, for a left-tailed test, just remember if the t was here, a negative t, and then the critical value, is negative, and then your t turned out to be here, then you reject. If your t turns out to be here, then you do not reject. Okay, but in our case, we have a right-tailed test, and we found that the t that we have here lies in the non-rejection region. So this means that you can say, therefore, do not reject the null hypothesis H0. But let me just tell you something. What if this t that you computed here, let's say it was from the given, you computed it and it was t equal 1.398, for example. If it was 1.398, it will be more than 1.397, so it will lie here to the right side. And then for this t, you would say reject the null hypothesis. Okay? But of course, our question was not this. Our question was, we got the t equal 1.253 when we used the formula here, and it turned out to be in the non-rejection region. And so our conclusion for this question is do not reject the null hypothesis H0. And I will stop here.